All right, so we are into the second half of the chapter 4 notes. We are going to be factoring again, but notice we're going to do something a little bit different. We've got an A in front of the X. So in all the examples we did in the last class, there was no A in front of the X. Now we've got terms in front. So notice here we've got 3x squared, whereas previously in the ones before we didn't have anything here. So with this, we are going to need to do a little bit of a different method. I'm going to show you two. So I actually just learned a new way to do this that's a little bit easier, but I'm going to show you a longer method that is very similar to the last lesson in case you want to do that one instead. So I'm going to show you that one first, and then I'm going to show the new one. You can pick which one you want to use. So for this, let's do this one. So I'm going to do something similar where I need two numbers that add up to this middle number 13 and two numbers that multiply, but because I have a term in front of the x squared, I need to multiply those two together. So it's what two numbers multiply to 3 times 4, so 12. What adds to 13? What multiplies to 12? So in order to do this, let's see, so this is just 12 and 1. So from that, I'm going to split up this middle term. So I'm going to end up with 3x squared plus 12x plus 1x plus 4. So getting the answers here doesn't give me my final solution. I'm not done that yet. So what I'm going to do next is I'm going to factor this. So I'm going to factor these two sections. So 3x squared plus 12x, I need to figure out what can I factor out of that. So I can factor out a 3x, and what I'm left with is, let's see, I've got x plus 4, and then I'm going to factor this. There's nothing to factor, so I can just factor out a 1 times x plus 4. These two brackets should be the same. If they're not, something's off. So you need to make sure that those two brackets are the same. And what that gives me is now my answer. So x plus 4 is one of the brackets. The other bracket is the leftover, so 3x plus 1. And that's my final answer. So that is one method you can use. Again, if you wanted to double check, multiply this out, you could get to that last answer. We'll see. But that's just a double check. I normally have taught this method because it has this, which is similar to what you've seen before. But I'm going to show you another method. Again, like I said, I just learned this method. It's actually quite a bit easier and a little bit quicker. But it's using basically the same kind of idea. So I want to figure out 6x squared plus 17x plus 12. So what we need is I'm going to set it up like this. So I'm going to make an x here, and I need to figure out what two numbers are going to add to this middle number, 17, and multiply to 6 times 12. So 6 times 12 being 72. So they need to add up to 17. They need to multiply to 72. So I need to go through and figure out, okay, what adds up to 17, what multiplies to 72, and then going through that and figuring out, you can get 9 and 8. So those two add up to 17 and multiply to 72. So then what you're going to do with this, so this is actually called the box method. What you're going to do for this is we are going to take our original terms. So 6x squared goes in the top box, 12 goes in the bottom right. So that's just taking it from my expression. And my two numbers that I figured out, 9 and 8, those go into the other two boxes. So 9x, 8x. The x because it comes from the middle term. And what I'm going to do with this box is I now need to figure out the factors of each of these columns. So I'm going to figure out with 6x squared and 9x, what is the greatest common factor of those? Well, I can factor out a 3, and I can factor out an x. So that gives me this column. Then I'm going to look at the next column, 8 and 12. so I can factor out a 4. And I'm going to do the same for the rows. So 6x squared and 8x, what can I factor out? Well, I can factor out a 2, and I can factor out an x. Same on the bottom. What's the common factor between those? So 9 and 12 can factor out a 3. And what you should be able to recognize, maybe some of you who are looking at this, is if I'm looking at a box, if I multiply these two together, I'll actually get this box. So 2x times 3x gives me 6x squared. If I took 3 times 4, that gives me 12. So you should be able to multiply back into that bracket. And the reason why this is so much easier is now this is my answer. It's just simply 3x. Now, because these are both positive, when I factor it out, it's going to be positive. So 3x plus 4 times 2x plus 3. And that's factored. So it's actually the same kind of method we did in the first one. It's just a different kind of notation with it. And eventually you can get to the point where you don't need this, this x. You can just do it with the box. So that's why I'm saying it's quicker. But if you don't like it, if you want to do the other method, that's fine as well. So I'm going to try another example here using the box just to show you that, because I don't know if you've seen it before. Let's make the box like this. So I'm going to fill in the boxes already. I can put 3x squared here. I can put minus 6 down here. And I'm looking for what two numbers add up to 7 and they need to multiply to 3 times negative 6. So if you want, you can write that down here just as a reminder. Negative 18 is what I want. So what adds to 7 and multiplies to negative 18? So because it multiplies to a negative, one has to be positive, one has to be negative. And in this case, we're going to have positive 9 and negative 2. Doesn't matter where you put them on here. You'll end up with the same brackets anyways. So there's my term, and I forgot to put the x's in here. So again, I can factor in the rows, factor in the columns. So looking at this column, 3x. Looking at this column, negative 2. Looking at this row, I've just got x. Looking at this row, I've got 3. And double check. You don't have to, but it's a good practice. Check the boxes. Make sure if I multiply the sides here, I get this. Negative 2 times x, negative 2x. 3x times 3 gives me 9x. Negative 2 times 3. Good. And then we've got our answers. So the top, 3x minus 2. So there's where the negative would come in, times x plus c. So that's your method. That's the way you can do this, and it's pretty straightforward. So what if you want to do the other ones, you can practice with those and double check in class. So now what if things are not looking exactly like you might expect them? Well, we can still arrange stuff like this. So for instance, what happens if you've got an x and you've got some y's in there as well? Well, the box method's great because it's going to do the exact same thing. So draw out the box. If you notice, I'm starting to like this one a lot more. It's a lot quicker to be able to do it. So I've got 3x squared up here, minus 10y squared down here. Just need to figure out these other two boxes. So what's going to add to negative 13 and multiply to negative 30? Well, can do this. Can figure out what's the multiples of negative 30, but you're going to get, let's see, so at first I was like 10 and 3 because I can add those up, but that would give me positive 30. So I would have to do negative 15 and positive 2. Double check that. Yeah, so that's what you would get. And again, now we've got xy, so we need to put xy into these boxes. And then again, just factor out the box, the rows and the columns. So factoring this column, I'll end up with 3x. Factor this column, I get 2y. Factor this, I just get x. Factor this, I get negative 5y, and there's my brackets. 3x minus 2y, x minus 5y. And you can multiply these back out, make sure you get the right answer, but that should give you that. And you're going to use the same method for these ones. So you'll notice, okay, this one they're trying to trick you. They've just rearranged it. So you just put it into negative 4x squared plus 5x plus 6, and then you do the same method. Easy peasy. This one, oh, they're tricking you. You've got an x squared and an, or sorry, x4, x squared instead of just an x squared by itself. No biggie. You just do the same method, and you'll end up with 2x squared terms instead of an x by itself. So you can give those as an extension problem and give those a try. And that is factoring when you have a term in front of the x squared. So with that, I will finish it, and I will answer your questions in class.